create a tangent curve, we will have the final points, and we will read in one way the points in the middle and one different way the corners. So we will start how we read the middle points. So the first thing we need to do is we need to create locators and another locator, and we are going to constrain this locator between this point and this point and this point and this point. Now we will create a curve, and we can be sure the curve is cubic. That will go from here to here. Now we can connect set node full position to the set node of the curve, the control point. Same for now the next things we need to do is we need to create a point that travels on that curve or allocator. We need to create a motion path to connect the curve and connect that to the locator. And the rotation. So on the motion path we can put the U value to be 0.5, and we are going to be using the aiming in X and up in Y, and we need to find a way to get this U value to be always close to this point. The way to do so is to create a node called nearest point of curve, and we will connect the locator to the locator world position to the in position, and the curve to the input curve. So this can give us the U value. We can connect the parameter to the motion path U value. So whenever we move now the locator or the other locator on the curve, we try to be as close as possible. So it's trying to go into it. Now we need to transfer the rotation of this object to a group that we're going to make children of this locator. So we will create a group, and we will parent it under the locator. So this group under this locator, and we will be sure that this group is is on the 0, which is on top of that. So we need to grab that tangent object and make an orientation constraint to this object. And now whenever we move, that group will orient the same way. So we need to create 2 more locators, make them the children of the actual group we just created. We will then 0, these are going to be our tangents, so they x amount of units in one direction and another x amount of units in the other direction. To find that distance or the amount of units we will need to move is the distance between this object and this object and this point or object. So we will need to create distance between node and another distance between node. We can connect that whole position to this point and the second and the same whole position to the other point. So that's the first distance. That will be the second distance between this pole position and first point and this. Pole position on the second point. So now we have the measure between the 2 points. So we need to convert that distance to the x position of this object and this object. So the easier way is to create when you know the utility, multiply another multiply later for the direction, so will be this distance to the x and the distance to the other axis. We will decide to, it's going to be always the third, like third part of the distance between the points. We can connect that to the other node. We're going to make one positive and one negative. So we can connect the output of the x to the output of the y to the input, and now we can connect this output in x to this object, translate in x, and the object translate in x. So as we see both on the same side, so we just need to change one to be positive, one to be negative. It's positive, this should be negative. Output the x to the input and the output of the y to the input y, and we can change the sign to be negative in one of the axes. We can output the x to the first locator on the translate x and output the y of the second locator here on the translate x. So one locator will be going on the positive, one locator will be going on the negative. We like sometimes to change that distance or that kind of percentage. We can create an attribute. That will be the weight between 0 and 1, and we can connect that weight to this multiplier that where we have like 0.3 before, so we could say now that is that weight. So now we can define on this main locator, we can define to this weight 0.33, and that will, you can change it to be shorter or bigger. Now we can hide what we don't need to see, or what we just need to keep. So we don't need to see this object for the in-between points. We have now the tangent. We can hide this help object we were using to be able to rent text. We have done the same thing we did for all the middle points, so that they'll have now the system with the tangents. And from the start and to the end of the curve, we just need to create a group that will be aiming to the tangent, and we will do the distance between this locator and this locator and have a weight, so we can make the same thing as before. We can just go 0.4 or 0.3. The same thing goes for the endpoint, where we have a aim group that is aiming to the tangent, and the weight that we can modify to make that distance smaller or bigger. So we are in a good spot to just create a curve. This time we'll create a Bezier curve, so it's 1 point, 2 points, 3 points, 4 points, and the end. We will need to connect the tangents. Before we do so, we can go and convert this curve into a NURBS curve, because right now it's a Bezier curve, and it's better for some nodes and some connections we can do in the future. So you go to modify, convert to, you can convert a Bezier curve to a NURBS curve. So now it will behave the same way with this Bezier curve that is being converted to a NURBS. So we have the tangents and we have the center point. One time we have connected the curve with all the locator world positions, we will have the brick setup. So we can see now that whenever I move any of the main locators, the tangents are kind of aligning to the next point. We can use the weight. So a good way to illustrate it is like if I make the weight really small, I will have a really sharp border. If I would have made the weight stronger, I will have a more open curve. And this curve is now better than Bezier curve or an up curve. And we only need to really animate or touch the main locators.